Okay, I recently came across an equation I thought was interesting, and it is related to what we're doing in class, trigonometric equation, and it's also related to what you did in Math 119. So it's 2 to the sine squared x plus 2 to the cosine squared x is equal to 3. And then the question is solve for x. I thought it was an interesting question. And again, it's related to what you've done in 119 and related to what you've done in Math 120. All right, so let me go through the method that I would recommend that you take. And the first thing I do is recognize that there is a Pythagorean identity over here. I just don't see its obvious application to the problem. But the sine squared plus cosine squared x is equal to 1 for all numbers, all right? So we verified that in class as well. Now, I'm looking at this over here. I could probably write, let's take a look. I could probably write the cosine squared x as 1 minus sine squared x, all right? That's not so bad. So what I'm going to do is take the equation, and I'll put that down for you. So 2 sine squared x plus 2. Now, instead of cosine, I can put down 1 minus sine squared x, and that equals the number 3. Now, I'm going to use rules of exponents, and I get 2 sine squared x plus 2 over 2 sine squared x equals 3. Now, of course, this looks pretty complicated. I'm going to make a substitution, which you learned about in Math 119. Now, if it's something difficult, make a substitution. So I'm going to say let u equal 2 sine squared x. If I do that, what do I get? I would get u plus 2 over u is equal to 3. What I do now is again, I'll have to go back in the problem because I don't really want to know what u is. I want to know what x is. Multiply both sides by u. What do you get? U squared plus 2u. I'm sorry, not 2u. My mistake. Let me go backwards. Plus 2. Give me one moment. Equals 3u. Again, I'm multiplying both sides by u. What do you get over here? U squared minus 3u plus 2 equals 0. By the way, I want to make sure you understand that u cannot equal 0. All right? What do you get over here? U, 0, 2, and 1. Minus, minus, and that does work out. So u could equal 1, or u could equal 2. Now, by the way, if I was solving for u, I'm done. I could check it. It kind of works out nicely. You know, for example, if you 1, you plug it in over here, you get 1 plus 2, which is 3. If you get 2, you get 2 plus 1 equals 3. That worked out nicely. But I want to point out, this is my trouble over here now. All right? So what do I get over there? I'll write this down for you. And u is equal to 2 sine squared x equals 1. Or, well, again, u is 2 to sine squared x is equal to 2. Well, I'm looking at these two equations, and the only way this would really work out, at least for this one over here, is if the sine squared of x equal to 0. And we can solve that. We know how to do that from the Math 120 techniques. And over here, this is really going to be the sine squared x is equal to 1. It's the only way it would work out. All right? Again, 2 to the 0 is 1, and 2 to the 1 is 2. All right, so what I'm going to do over here is, make an attempt to solve this. And to do that, what do I notice is this simply says the sine of x is equal plus or minus the square root of 0, which is just 0. And certainly, I know when that occurs, if I were to look at that, I would get something like this. So all I'd say is that the multiples of pi. That's all I'd say, all right? So I'd say x equals the multiples of pi, with the understanding that k is some integer. If I look at the other one, a little more complicated, sine x equals plus or minus square root of 1. Well, that looks pretty easy too, because it's going to be here or here. So now when I'm looking at my picture, that really this occurs, right? Just by looking at this picture, I want to point out what I mean by that. Let me get my red pen out. I'm noticing just hits here. So what is it really going to be? It's just the multiples of pi over 2. So I want to write that down for you. So instead of writing down answers in pieces, what do I now know? I know x equals pi over 2k. This is my final answer. All right, I'm also going to go and show you in software, right? I'm going to use software to verify this. All right, so I'm going to verify using software. All right, thank you.